Hello and welcome to more conditional probability. We're going to look today at Rebecca and her books. She has 75 books in her libraries and she categorizes them this way: fiction, nonfiction, teens, and adults. This is called a two-way table because the information is presented in two different ways. There's two different pieces of information about them. So the first thing, we always want to find the totals first if we have a two-way table. I've already done that for you. These are in bold, so we don't need to do extra totals. The totals are already here. The first question is asking, find the probability of finding a book for a teen. So out of all of her books, she's got 75 of them. If we were to just reach into this big pile of books, what's the probability that the book that we pull out is a book that's for teens? Well, how many books for teens are there? There are 50 total books for teens out of the 75. So this is our probability. We can reduce this to 2/3, but I'm okay with leaving that. The next one is find the probability that it's fiction. So out of the 75 big books in the pile, if I reach in and grab a book, what's the probability the book I grabbed is a fiction book? Well, how many fiction books are there? There are 30 fiction books total out of the 75. Some of them are for teens, some of them are for adults, but all of them altogether, they're all fiction books, 30 of them. Now this is the conditional probability. What's the probability of grabbing a book for teens given that it's fiction? So we want to work backwards and look at this part first. Say, okay, let's just put these 30 fiction books in a pile so that we know the book is fiction. So here's 30 of them, and we reach into this pile of 30 fiction books. What's the probability that that book is a book for teens? Well, out of the 30 fiction books, how many of them are for teens? 20. So we have 20 out of 30. We know this first, that's our denominator, then we find the probability of this happening. Same thing here. What's the probability of a fiction book given it's a book for teens? So we have to look first at the books for teens. How many books for teens are there? There are 50 of those. Okay, so we put those 50 books in a pile, and out of that, because we know it has to be a book for teens, find the probability that the book that I pull is a fiction book. Well, out of the 50, how many of these are fiction? 30 nonfiction, 20 fiction, so 20 out of 50. The next question asks if they are independent events. We know that there is a formula that will work if they are independent events, and that is this one. So we need to see, does this actually indeed work? So let's find what these numbers are. The probability of A and B, that's probability of a book for teens and fiction. How many books are teens and fiction? There are 20 that are for teens and fiction out of the total. So the probability of reaching in and grabbing one that is both teens and fiction is a probability of 20 out of 75. The probability of finding a book for teens, we already did that one right up here, book for teens, 50 out of 75. And this one, fiction, is 30 out of 75. So if I go to the calculator, this one is 0.6666666. This one is 0.4. And if I multiply those, calculator, I get 0.2666. Now if I divide 20 divided by 75, does that equal this side? 20 divided by 75 is 0.266 also. Oh, there's a 2 in there. 266. So because these, oh, that's so sloppy. 266. Ignore this sloppy. So because these are equal, therefore, the formula works. So yes, they are independent, which means one outcome does not affect the other. They are no more likely to be for teens than for adults if they're given their fictionness or not fictionness. You could have also used this formula, probability of A equals probability of A given B. That will also work. Or B equals B given A. Okay, the next one asks about, are they mutually exclusive? That means are the two outcomes separate, or is there any way they can both happen? Can you have books that are both for teens and also fiction? Or should the fiction go over here? Or are there some books that are both? Well, we just found there were 20 books that were both. There is an overlap. Here's our fiction. There are 20 books that are in both, so they are not mutually exclusive because 20 books are both. If you couldn't possibly have both, then they would be separate and they'd be mutually exclusive. Find the probability of the book for teens and fiction. We just found that there were 20 of them out of the 75. Probability of the book is for teens or fiction. Now that's a little different because now we have to consider all the teen books. How many teen books are there? Total, there were 50 teen books. So that's in this first circle here. There are 50 of those. Plus all the fiction books. There were 30 fiction books. But we've counted all of this, and we've counted all of this. But remember, there were 20 in the overlap that we double counted. So let's subtract those ones that we double counted over 75. And that's a total of 80 minus 20 is 60 over 75. You could also look at the table with this one and say, okay, let's do all of these plus all of these minus the overlap that we counted twice. That's conditional probability.